Welcome to Future Forward, everyone. I'm Alex, and with me, as always, is my curious and quick-witted co-host, Rowan.
Hey there, I'm already intrigued by today's topic, Alex. I heard you mentioning something about AI that can actually understand photos and conversation at the same time.
That's right. We're diving into something truly fascinating today, multimodal AI. Imagine showing an AI system a family photo, telling it about the memory behind it, and having it respond with the understanding of a close friend. This isn't science fiction anymore, it's happening right now.
Wait, so these systems can process multiple types of input at once, like seeing and hearing?
Exactly. And it's completely transforming how we interact with computers. We've moved way beyond the days of just typing commands into a keyboard. These systems can now see, hear, and even understand context in ways that feel almost human.
I'm getting both excited and slightly nervous about this. I mean, the possibilities sound amazing, but there must be some pretty big implications here.
Oh, there definitely are. And that's exactly what we'll be exploring today, from how these systems evolved to the $50 billion industry they've created right through to the ethical questions they're raising. We'll even look at how they're being used in everything from healthcare to creating art.
Sounds like we've got quite a journey ahead.
We absolutely do. Let's get started. Let me take you back to the early 2000s when AI systems were a lot like specialized tools. Each one was designed to do just one thing, like recognizing faces or processing text, but they couldn't really work together.
Sort of like having separate apps for everything on your phone, instead of one that can handle multiple tasks.
That's a great analogy. And just like how smartphones evolved to handle multiple tasks seamlessly, AI underwent a similar transformation. The real game changer came with something called transformer architecture.
Transformers. Please tell me this has nothing to do with robots in disguise.
Not quite that kind of transformer. These transformers are actually a special type of neural network that can process different types of information in a unified way. Think of it as a universal translator for different types of data.
So how exactly does that work?
Well, according to recent research, transformer architecture treats all kinds of input, whether it's text, images, or sound, as nodes in a connected network. It's like having a universal language that can describe anything, whether you're looking at a photo or reading a paragraph.
That sounds incredible, but I'm trying to wrap my head around how a computer can understand such different types of information in the same way. I mean, surely processing an image is completely different from processing text.
You'd think so, but that's where the brilliance of this approach comes in. The transformer uses something called self-attention, which helps it understand the relationships between different parts of the input, regardless of what type of data it is.
Okay, so it's kind of like how our brains can naturally connect what we see with what we hear.
Exactly. And just like our brains, these systems can now make connections across different types of information. For instance, you can show it an image and ask questions about it, and it will understand both the visual content and your text query to give you a meaningful response.
I've actually seen some examples of this, like those AI art generators where you can describe what you want and they create an image. Is that the same technology?
That's one application, yes, but it goes even further. These systems can now understand context and nuance across multiple types of input. The research shows that this approach helps AI work in what they call a modality-agnostic pipeline.
Modality what now?
Sorry, but let me break that down. Modality-agnostic means it doesn't matter what type of input you give it. Text, images, audio, the system can process it all using the same underlying principles. It's like having a universal translator that works for any form of communication.
So we've basically taught computers to be multilingual, but instead of just different human languages, they can understand the language of images, text, and sound all at once?
That's a fantastic way to put it. And this breakthrough has opened up so many possibilities. We're now seeing systems that can understand videos, generate images from descriptions, and even help doctors analyze medical images while taking into account written patient histories.
It's amazing how far we've come from those early specialized systems. Though I can't help but wonder what made this massive leap possible.
Well, it wasn't just one thing. The research points to several key developments. Deep neural networks that can recognize patterns like our brains do, advanced natural language processing, and something called multimodal fusion, which helps combine different types of information in meaningful ways.
Sounds like a perfect storm of technological breakthroughs.
Exactly. And what's really exciting is that we're still just at the beginning of understanding what these systems can do. Every day, researchers are finding new ways to combine different types of input to solve complex problems.
I'm getting the feeling this is going to change a lot more than just how we interact with computers.
You're absolutely right about that. And speaking of changes, there's another fascinating aspect of this technology that we should explore. You know what's fascinating about all this technological progress we've been discussing? The absolutely massive financial investment that's making it possible. We're talking about some of the biggest numbers I've ever seen in tech investment.
How massive are we talking about here?
Well, just this month, in April 2025, OpenAI raised $40 billion in a single funding round. That's the largest private tech deal ever recorded.
40 billion in one round? That's just, I can't even wrap my head around that number.
And here's what's even more interesting. That's just one piece of the puzzle. SoftBank put in $30 billion, Microsoft invested $14 billion, and Amazon Web Services contributed $8 billion. We're seeing a real arms race in multimodal AI development.
Sounds like everyone wants a piece of this pie, but why such enormous amounts? What are they actually spending all this money on?
A lot of it goes into infrastructure. For example, OpenAI just signed an $11.9 billion agreement with CoreWeave for AI infrastructure, including access to hundreds of thousands of NVIDIA GPUs. These systems need incredible computing power to process all these different types of data simultaneously.
Wait, so they're not just developing software, they're building actual physical infrastructure too?
Exactly. And it's not just OpenAI. Microsoft announced an $80 billion commitment to AI-enabled data centers just this January. Google's been pouring billions into both hardware and software development, with their search business, now AI integrated, bringing in $48 billion in just one quarter.
I'm noticing a pattern here. These are all the big tech companies we already know. Is this becoming another Silicon Valley monopoly situation?
That's a really insightful observation. We're seeing an interesting dynamic where these companies are both competing and collaborating. Microsoft has that major partnership with OpenAI, while Google's developing its own systems like the Gemini AI model.
I've heard of Gemini. That's the one that can understand both images and text, right?
Right, it's got 137 billion parameters and was trained on 1.56 trillion words. But what's really interesting is how these companies are trying to reduce their dependence on each other. OpenAI is working with Broadcom to design their own AI chips, trying to become less reliant on NVIDIA's GPUs.
So they're basically trying to build their own complete ecosystems? Sounds expensive.
It is. But there's also this fascinating initiative called Stargate. OpenAI announced it with SoftBank and the current administration, committing $500 billion to AI infrastructure over 4 years.
500 billion? That's $500 billion. Are these investments actually paying off?
Well, looking at OpenAI's growth, their revenue increased by more than 3,600 times from 2020 to now. And they're not just focusing on profit. They've committed $50 million to AI research and education through their Next Gen AI initiative.
I notice you keep mentioning infrastructure. Is that where most of this money is going?
A huge portion. Yes, these multimodal systems need massive computing power. Microsoft's data center expansion includes specialized GPUs and AI accelerator chips. They're basically building the foundation for the next generation of AI.
It's starting to sound like the space race, but for AI. Everyone's trying to be first. At first, investing astronomical amount.
That's a brilliant comparison. And just like the space race, this competition is driving innovation at an incredible pace. Each company is pushing the others to develop better, more capable systems.
But surely there must be risks with this much money and power concentrated in so few hands.
That's a crucial point, and it leads us to another important aspect of this story that we should explore. You know what's really exciting about all this technological advancement? It's not just theoretical anymore. These multimodal AI systems are making real differences in crucial fields like healthcare right now.
I've heard something about AI reading X-rays. Is that what you mean?
That's part of it. Massachusetts General Hospital and MIT created an AI system that's actually outperforming human radiologists. Their system achieved 94% accuracy in detecting lung nodules, while human radiologists averaged around 65%.
Wow, that's a pretty significant difference. But how does the multimodal part come into play here?
Well, that's where it gets really interesting. At Mass General Brigham, they're not just looking at images in isolation. The AI analyzes medical imaging alongside electronic health records and other patient data all at once. It's like having a doctor who can instantly process and connect every piece of information about a patient.
So it's combining visual data from scans with written medical histories? That sounds incredibly useful.
Exactly. And at Stanford Healthcare, they're using this technology for early detection of patient deterioration and sepsis. The system monitors multiple data streams simultaneously: genetic information, clinical data, imaging, all working together to spot potential problems before they become critical.
I can see how having all that information working together would be valuable. But what about accuracy? I mean, we're talking about people's health here.
That's a great question. Recent studies of ChatGPT 4V in clinical settings showed it achieved 77% accuracy on medical board-style questions when given both images and patient histories. That's approaching human-level performance.
That's impressive. But you mentioned creative arts earlier. How does this same technology work in such a different field?
This is where it gets really fascinating. These systems are now creating original artwork by understanding both visual art and written descriptions. They can analyze the styles of historical masters and create new pieces that capture those same techniques.
Like those AI art generators we mentioned earlier?
Yes, but it goes way beyond that now. The most successful implementations are actually collaborations between human artists and AI. The AI can process and understand multiple artistic mediums at once: visual art, music, even poetry, while the human artists provide the emotional depth and creative direction.
That sounds like it could either be really amazing or really concerning, depending on how you look at it.
You're right, and that's why the most celebrated achievements are coming from this hybrid approach. The AI handles the technical aspects, processing patterns, generating variations, suggesting combinations, while human artists make the crucial creative decisions.
Can you give me a specific example of how this works?
Sure, let's say a musician wants to create a piece inspired by a famous painting. The AI can analyze both the visual elements of the artwork and the artist's musical preferences, then suggest melodic patterns that capture the painting's mood and structure. The musician then takes these suggestions and crafts them into a final composition.
That's actually pretty cool. It's like having an incredibly knowledgeable creative partner who can see connections we might miss.
Exactly. And what's really interesting is how these different applications, whether in healthcare or the arts, are starting to influence each other. The pattern recognition techniques that help diagnose diseases are similar to those used to analyze artistic styles.
So the same basic technology can be adapted for completely different purposes?
Precisely. It's all about understanding patterns and relationships across different types of information. Whether you're looking for early signs of disease or creating a new piece of music, the underlying principle is the same: making meaningful connections between different types of data.
It's amazing how versatile these systems are becoming.
And we're really just scratching the surface. Every day, researchers and practitioners are finding new ways to apply this technology to solve complex problems and create new possibilities. You know, for all the amazing capabilities we've discussed, there's another layer to multimodal AI that we need to talk about: the ethical implications of systems that can understand and respond to human emotions.
I was wondering when we'd get to this. It does feel like we're entering some pretty complex territory when AI can read our emotions.
According to recent research from Stanford's Institute for Human-Centered AI, these systems are becoming remarkably good at detecting emotional states by combining facial expressions, voice patterns, and text analysis. But that raises some serious questions about privacy and consent.
I can see how that might be problematic. I mean, do we really want AI systems knowing when we're feeling vulnerable or upset?
Exactly. The World Health Organization actually raised concerns about this recently, warning that these systems might be deployed faster than we can make them safe. There's particular concern about how this technology could be used for emotional manipulation.
What do you mean by emotional manipulation?
Well, imagine an AI system that knows exactly when you're feeling down and uses that information to show you targeted advertisements. Or one that can craft perfectly timed messages designed to influence your political views based on your emotional state.
That's actually pretty scary. Are there documented cases of this happening?
Yes, unfortunately. Research has shown that multimodal systems can infer things like political leanings or personal beliefs from seemingly unrelated data, even when users haven't explicitly shared that information.
Wait, so these systems might know more about us than we've actually told them?
That's right. And it gets more complicated when you consider bias in these systems. When biases exist in any single type of data, like facial recognition or voice analysis, combining them can actually amplify the discrimination.
Can you give me an example of how that works?
Sure. Consider a hiring tool that uses both resume text and video interviews. If it has biases against certain accents or appearances, and combines that with biases in how different groups write resumes, it could end up excluding qualified candidates from multiple angles.
I've never thought about it that way, one bias reinforcing another.
And here's what's particularly concerning. These systems are processing massive amounts of personal data across multiple channels. Every photo, every voice command, every text message becomes part of a larger pattern that can be analyzed.
So our privacy isn't just about individual pieces of information anymore. It's about all these different types of data being connected?
Exactly. The Stanford research shows that even when each piece of data seems harmless on its own, combining them can reveal surprisingly intimate details about our lives. Something as simple as matching photo locations with message timestamps could reveal someone's daily routine.
That's unsettling. Are there any safeguards being put in place?
There are efforts. Experts are recommending strict access controls, anonymization, and data minimization. But the challenge is significant because of how these systems work. They're designed to find connections and patterns across different types of data.
Sounds like we're in a bit of a catch-22. The very thing that makes these systems powerful also makes them potentially dangerous.
That's a perfect way to put it. And it's why there's such an urgent call for better oversight and regulation. We need to ensure these systems respect privacy and emotional boundaries while still maintaining their beneficial capabilities.
I guess the question is, how do we balance the amazing potential of this technology with the need to protect people's privacy and emotional well-being?
That's exactly what researchers and ethicists are grappling with right now. They're working to develop frameworks that can help us navigate these challenges while still allowing for innovation and progress.
It's definitely given me a lot to think about. I mean, I'm excited about the possibilities, but also more aware of the risks.
And that's exactly the kind of balanced perspective we need to have as this technology continues to evolve. We need to stay informed and engaged in these discussions about ethics and privacy. You know what fascinates me most about where this technology is heading? The way multimodal AI is completely transforming our perception of reality through AR and VR experiences.
Oh yeah, I've been seeing a lot about that lately. Are we talking about those new smart glasses everyone's wearing?
That's part of it, but what's really groundbreaking is how these systems are creating what researchers call emotionally aware virtual environments. The latest research shows these environments can actually adapt in real time based on how you're feeling.
Wait, so the virtual world changes based on my emotional state? How does that work?
Well, imagine you're in a virtual meeting room and the system detects you're getting stressed. It might subtly adjust the lighting, change the background sounds, or even modify the behavior of virtual characters to help you feel more at ease.
That sounds both amazing and slightly unsettling. Are people actually using this technology now?
They are. According to recent industry forecasts, we're seeing rapid integration of these systems, especially in training and education. For instance, medical students are now training with virtual patients that can respond to their tone of voice, facial expressions, and even their level of confidence.
So the virtual patients actually pick up on how confident the student feels? That's incredible.
Exactly. And what's really interesting is how these systems are becoming more sophisticated in processing multiple inputs simultaneously. They're not just looking at your facial expressions, they're combining that with your voice patterns, gestures, even subtle changes in how you move.
I can see how this could be really useful for training, but what about everyday applications?
That's where it gets really exciting. The latest developments show these systems being integrated into what they're calling ambient computing environments. Your whole living space becomes responsive to your needs and emotional state.
Like a mood ring for your entire house?
More sophisticated than that. Think of it as an environment that understands context. If you're working from home and showing signs of stress, it might adjust the lighting, suggest a break, or even initiate a calming virtual experience.
But how does it balance being helpful with, not being creepy?
That's a crucial question. The research emphasizes the importance of what they call graceful integration, where the technology enhances our experience without being intrusive. It's about subtle adjustments rather than obvious interventions.
I'm trying to imagine what this means for social interactions. Like, if I'm in a virtual meeting, can everyone see how I'm really feeling?
The systems actually include privacy controls that let you decide what emotional information is shared and with whom. It's similar to how we naturally control our emotional expression in different social contexts.
That's reassuring. But where is all this heading? What's the next big development we should be watching for?
Well, one of the most promising areas is something called cross-reality experiences. These systems will seamlessly blend physical and digital worlds using multimodal AI to create what researchers call continuous adaptive experiences.
That sounds intriguing, but what does it actually mean in practice?
Imagine walking down a street and seeing historical events unfold around you, with the AI system adjusting the experience based on your interests and emotional responses. Or attending a concert where the music and visuals adapt to the collective mood of the audience.
So it's not just about individual experiences anymore, it's about shared emotional spaces?
Exactly. And this is where the technology gets really transformative. These systems are creating new forms of social interaction and shared experience that we're only beginning to understand.
It's starting to sound less like science fiction and more like, just science.
That's because we're at a point where the theoretical is becoming practical. These aren't just ideas anymore. They're becoming part of our daily reality. You know, Rowan, looking back at everything we've covered today, I can't help but feel we're witnessing something truly transformative. Multimodal AI isn't just another technological advancement, it's fundamentally changing how we interact with machines and with each other.
I'm struck by how it's breaking down barriers between different types of communication. It's like we're moving beyond the limitations of any single way of expressing ourselves.
Exactly. And what's fascinating is how these systems are becoming more, well, human in their understanding. They're not just processing information, but they're grasping context, emotion, and nuance across multiple channels simultaneously.
Though I have to say that comes with both excitement and concern. I mean, the potential in healthcare and education is amazing, but those privacy and ethical questions we discussed are pretty serious.
That's why I think it's so important that we stay engaged in these conversations. We're not just passive observers in this transformation, we're active participants in shaping how this technology develops.
So, what's your take on where all this is heading?
I think we're moving toward a world where the boundaries between digital and physical reality will become increasingly fluid. But the real question isn't just about what these systems can do, it's about how we choose to use them.
To enhance our human capabilities rather than replace them?
Precisely. As these systems become more sophisticated, our challenge will be maintaining that delicate balance, using them to augment our natural abilities while preserving what makes us uniquely human.